Hey guys, today we are going to be starting with section 4.3 in chapter 4, area of trapezoids. You can find this section on page 168 in your textbook. As you can see here in our first example, example 1, we have some shapes of trapezoids. Trapezoids are a shape that has only one pair of parallel sides. In this case, in example A, you can see these two sides are parallel and these two sides are parallel. These sides here are not parallel with each other. Another way you might see a trapezoid sometimes is drawn like this. Notice again the top and bottom are parallel to each other, and the left and right sides are not parallel to each other, and that is what gives us a trapezoid. And that's different from a parallelogram that we learned about last week. A parallelogram has two pairs of parallel sides, so these sides here would then be parallel to each other. That would create a parallelogram. So the formula for a trapezoid, we're going to go ahead and get started with our notes. The formula for the trapezoid, we're going to start writing it in words. The area of a trapezoid is half the product of its height and the sum of its bases. So area of trapezoid is half the product, and remember product means multiplication, of its height and, so it's going to be multiplied by, the sum, which is addition, of its bases. Now there's a lot going on in that sentence. What are we talking about? We're going to write it out in words, or not in words now, we're going to write it mathematically, and I'm actually going to, I was going to zoom in. I won't zoom in. And mathematically, we're going to write this as A equals 1/2 height times the sum of its two bases, base 1 plus base 2. What we're talking about with base 1 and base 2, see how down here this is one of our bases. This base is different than the length of this base. So in a trapezoid, both of the bases are going to be different lengths. So when we're talking about base 1 and base 2, we're talking about the two parallel sides. In this case, 9 feet would be base 1 and 5 feet would be base 2. Now, I want to write this another way. Much like multiplying when finding the area of a triangle, a lot of you learned that instead of multiplying by half, it's the same thing as dividing by 2. So we can also write this as A equals, the area equals, height of the trapezoid multiplied by base 1 plus base 2 divided, all of it together, divided by 2. So we can try that on various problems today. We'll go back and forth between both methods, and you can see which one makes the most sense or works best for you. Let's jump right down into example 1. We'll get started in solving a few of these. We're still using our OSS method. A lot of you guys know it as ESS, that original equation. Remember, if you're using ESS, you're just talking about the equation, and that's the formula for the area. So right here with example number 1, 1a, we've got to solve for the area. We're going to start with our original equation. A equals, for this one I will use this one right here, 1/2 the height times base 1 plus base 2. Then we'll go ahead and substitute, and when we're substituting in, we're going to be using our height right here as this number. The height is between the two bases, and it meets the two bases at a right angle, straight up and down, and this little box right here represents our right angle. So A equals 1/2. We're going to plug in 6 feet for our height, that's right here, and base 1 is our 9 feet, plus base 2, which is 5 feet. We can go ahead and solve that now. A equals 1/2 times 6 plus 9 plus 5 is 14. A equals, when we add 6 and 14, we get, when we multiply 6 and 14, we get 84. So we're taking 1/2 of 84, and we end up with 42, and this is in feet, so feet squared. All right, let's go ahead into example 1b now. I'm going to use this method this time. Oh, I'm circling it. A equals the height times the sum of the two bases, then divided by 2, rather than multiplying by half this time. So our original equation, A equals height times base 1 plus base 2, all of that divided by 2. Area equals, let's substitute in now. I've got my 5 for my height. That's the straight line that meets at a right angle between our two bases. And base 1, we've got 11.5. I know it's hard to see that 0.5, but that should be a 0.5. Plus base 2, put a little point in there. Hopefully it shows up. And our base 2 is then going to be 8.5. Again, I know it's a little hard to see. Divide all of that by 2. Let's go ahead and solve now. A equals 5 times. When we add 11.5 and 8.5, we end up with 20. Divide by 2. We know that 5 times 20 is 100. 100 divided by 2 then, we end up with 50. And in this case, we are talking about meters squared. Okay. Moving on down to the bottom here, we are on example number 2. In this case, we have our grid line, so we're finding the area of a trapezoid within a grid. Step 1, we're going to count the grid lines to determine the measurements for the bases, both base 1 and base 2, and the height, and then we're going to find the area using OSS like before. Now, one thing I want you guys to keep in mind, when we're counting the grid lines, we're counting the entire line for the block, not counting just the points. So if you were to make a mistake and just count the points, you'd count this 1 point, 2 points, and 3 points, when really we're only covering 2 squares of the grid lines. So we're counting this 1 square as 1 and this 1 square as 2, and that gives us our 2. Now remember, our bases are always the 2 parallel lines from each other. So in this case, these are our parallel lines. These 2 lines, although they kind of look close to parallel, they're not. If we were to continue these lines out, eventually they would intersect and hit each other out over that way. So this is kind of like one of these trapezoids up here, but tilted on its side. So we've got our base 1, which is 2, and then our base 2 up here, that's only 1 grid line or 1 box line, and that would give us our 1 for base 2. And now we need to count our height. Now remember, our height is our straight line. If we look back up here, that meets at a right angle between our two bases. We could either count this up here as our height, but I also see that there is a line that runs straight through our trapezoid that can be counted as our height. We can go ahead and count that. We've got 1 grid line, 2, 3, 4, 5, and 6. So then our height would be 6. Using our OSS formula, A equals, this time I'll head back to my 1/2. 1/2 height times base 1 plus base 2. A equals 1/2. My height I found is 6, substituting in now. Base 1 we know is 2 plus 1. Let's go ahead and solve. A equals 1/2. 6 times 3. A equals 1/2. We know that 6 times 3 is 18, so we end up with an area of 1/2 of 18 gives us 9, and we don't have units, so we're just going to say units squared. Alright guys, go ahead and flip your paper over. We're going to work on example number 3. It's our real life application problem, our word problem. You can use a trapezoid to approximate the shape of Scott Country, Virginia. The population is about 23,200 people. About how many people are there per square mile? All right, so in this whole area here, this is Scott Country. No, I'm sorry, that says county. This is Scott County, Virginia. In this whole area here, which we're going to figure out, there are 23,200 people. We want to find out how many square miles there are. Square miles would give us our area. And then we're going to find out how many people per square mile. So we'll just start with finding the area using the formula we had just used. So let me get my pen. All right, our original formula, A equals. We'll switch back now and do our height times base 1 plus base 2, all divided by 2. Not sure which method you like better. Substitution. area equals. If we take a look over at Scott County, Virginia, we see this is our base 2, this is our base 1, and our height is right here in the middle. So our height is going to be 20 miles. Base 1, they're using the top as their base 1, it doesn't really matter which. 15, and the bottom is base 2. We've got 38. Divide it all by 2. Let's solve. A equals 20 times 15 plus 38. That gives us 53. All divided by 2. Area equals, if we do 20 times 53, we end up with 1060 divided by 2. 1060 divided by 2 gives us 530. So we just found that the area of Scott County, Virginia is 530 square miles, or miles squared, either way you write it. So we know that there's a total of 23,200 people per every, let's do people, 530 square miles. What they're asking us is, if we go back to our problem, about how many people are there per square mile. So that means they're talking about for every 1 square mile. So if we were to turn this into like a ratio, 1 square mile, it's kind of like a unit rate. How can we get from 530 square miles to 1 square miles? Well, we would divide by 530, wouldn't we? Whatever we do to the bottom, we must do to the top. Divide by 530. And you can look at it this way too. We're just taking this 23,200 and dividing by 530 to get how many people per square mile. If we go ahead and put that in our calculators, 23,200 divided by 530, we end up with roughly 43.77 people per square mile. Well, it's hard to have a decimal of people, so we're going to say that is roughly, these little squiggly equal signs means like about 44 people per square mile. All right, that's it for this video. Next up would be 4.3 extension, the area of composite figures. So great job with the area of trapezoids. Let me know if you have any questions at all. Go ahead and rewind if you want to go over another concept or get some more practice. See ya!